Alright, today is Introduction to Energy. This is part 2. We're going to focus on forms of energy today. Last class we worked on potential and kinetic. Today we're working on forms. So the big idea here is there are different forms of energy, and we can transform it from one form to another. Okay. So kinetic and potential energy are the two types that we talked about last class. And here's a diagram. And if you have kinetic energy, it's any type of energy that's in motion. And the forms of kinetic energy are light, wind or motion energy, thermal, sound, electrical. So these are any type of energy that's in motion is kinetic energy. And here's some examples of potential energy. Gravitational, the earth pulling down on an object if it's like a book on top of a shelf. Chemical. Okay. Elastic, that's like a stretching rubber band. Nuclear, electrical, these are all different types of forms of potential energy. Anything in red you're going to write down on your notes. And remember, our question for this section is what forms can energy take? So you want to write this down, right, on the side. Right? Energy is expressed in joules. That's how we measure energy. It's in a unit called joules. The first one we want to talk about is mechanical energy. And mechanical energy is energy in position and motion. So if you're moving something like a hammer, that's mechanical energy. If something's moving, like our spool racers were moving, that's mechanical energy. Mechanical energy can also be if you stretch something out, like a rubber band. So with our spool racers, we had our rubber band. Okay, our rubber band was stretched out, and as we wound it, and that was mechanical energy as well. Okay. Sound energy is kinetic energy caused by the vibrations of particles in the medium, such as steel, water, air. So sound energy is a form of kinetic energy, okay? And that's how we hear vibrations in the air or some type of medium. Light or electromagnetic energy is energy transmitted through space in the form of electromagnetic waves. So when you see light coming from the sun, that is electromagnetic energy. These are all the different forms of electromagnetic energy or light waves. Some you can see, which is right here. That's all we can see is this the Roy G. Biv. And some you can't, like ultraviolet, gamma rays, X-rays. You get at the dentist, you can't see those. We're going to have a whole unit on this later on in the year. Electrical energy is the energy that results from charged particles. So when electrons are moving through wires, that's electrical energy. So charged particles, right? Position or motion of charged particles. So if you have a light bulb with a battery or flashlight, the little electrons move through the wire into the light bulb and then back over here to the battery again. And that's electrical energy. Chemical energy is a form of potential energy. And this energy is like gas or the food you eat. Pieces of paper. It's all energy that's stored in the bonds or the molecules of atoms. Okay? So when you eat food, okay, you digest it, you break down those molecules, and you use those molecules for energy. Okay? Thermal energy is a type of kinetic energy. Okay? And thermal energy is the motion of particles. Okay? So the faster something moves, the particles move, the more energy it has. That's thermal energy. A good example here is heat. And we're going to have a whole unit on heat energy, okay, later in the year. So heat is a energy transfer from one object at a higher temperature to an object at a lower temperatures. So when you feel that heat, that's what's happening. The particles in the air are moving faster, and it feels warmer. Okay. Another form of energy, and this is a type of potential energy, is nuclear energy. And nuclear energy comes from energy inside the nucleus of an atom. So it can either break, so an atom's nucleus can either break apart, we call that fission, or can join together, and we call that fusion. So that's nuclear energy, when atoms either break apart or join together, and you get energy that is released. So let's take a look at this little picture here. Okay, what forms of energy can you identify in this pinball game? So some of the forms of energy, if you were thinking, you have mechanical energy because the little paddles are moving. The ball moves around, bounces off. That's mechanical energy. You might have light energy. Okay, Once it hits something, it starts to light up. You could have sound energy. Okay, you could hear the ball running. Maybe it has a bell in there. There's also electrical energy that makes the whole game work. So there's all kinds of different types of energy in this pinball game, and it's all going from one form to another. So here's our next thing. What is energy transformation? Okay, so on your Cornell notes, you want to write the question, what is energy transformation? Now, anything in red is what goes on the right side, and we're going to talk about energy transformation, because energy can always change from one form to another. So energy transformation takes place when energy changes from one form to another, and any form of energy can change to any other form. So here's a good example here. An automobile or a car takes chemical energy and makes it mechanical energy and heat energy. So the gasoline you put in a car is chemical energy. The car moving, the engine running, is mechanical, and you also feel heat. Okay. We can go down here, a tree. A tree takes the light energy you learned in life science and changes it to chemical energy through photosynthesis. So light energy to chemical energy. The hammer, this is hammering a nail, changes mechanical energy into heat energy, because when you hit that nail, you get a little bit of friction, and that friction turns to heat. So mechanical or motion energy, okay, to heat energy. This is supposed to be like a nuclear reaction inside the sun, or maybe you could think of an atomic bomb. And a thermonuclear reaction changes nuclear energy into light and heat energy. So the sun, inside the sun, is nuclear fusion, the atoms combined. And what happens is it produces that heat and that light we get from the sun. So very important, nuclear energy to radiant and heat energy. Radiant is another way to say light. Electrical energy here in the mixer is going to be changing to mechanical and heat energy. So this is electric. Electricity comes in here. We get that mechanical. The motor might run and get a little bit of heat. You also get something else. Right? It's sound energy, because you can actually hear the motor running and hear the mixer going. So we change from one form to 2 or 3 other forms. Okay. Here is electrical energy, and this is going to light or radiant energy, but also heat. If you feel heat off a light bulb, you can feel that. So often one form of energy changes into more than one other form. You get multiple forms. Okay, here's a flashlight. Now this flashlight, okay, takes the chemical energy in the batteries, okay, and transforms it into electrical energy, so it goes through the wire. Then the electrical energy is transformed into light, from the light coming out, and a little bit of heat. Even though you don't feel it, there's a little bit of heat coming off that too. So those are the energy transformations in a flashlight. All right, the last thing here is really important, okay, and is energy conserved. So this is another question we want to write on the left side, okay, and these are our notes. So is energy conserved? Okay, in a closed system, okay, which is a group of objects transfers energy only from one to another. Energy is always conserved in that system. What that means is you can't destroy energy and you can't create energy. So that we call this the law of conservation of energy. Energy cannot be created or destroyed. It can only go from one form to another. So all the different forms of energy in a closed system always adds up to the total amount of energy. Okay. So that's the law of conservation of energy. If I could look at the energy that my computer uses, the energy that comes in can be transformed into energy that goes out, and you're not really going to lose any energy. It just might change to light on the computer. It might change to heat, sound. So it's just changing from one form to another. Okay. All the energy in the universe has always been here, and it just goes from one form to another. That's the main idea with the law of conservation of energy. Okay. You're going to do a little mini lab in your groups. You're going to rotate around the room when you come back, and we're going to analyze energy transformations from one form to another.